Every time I opened a new AI chat to work on my homelab, I had to explain everything from scratch. The cluster layout, how the deployment pipeline works, why the config is structured the way it is. The naming conventions that made sense 6 months ago and that I only half remember now. Think about what it would be like if you hired a new engineer for your team. Smart, capable, ready to help. But every single morning they show up with zero memory of the day before. You brief them on the project, the code base, the conventions every single morning. You'd lose your mind. That's what working with an AI on a complex home lab feels like. Except the AI is faster, doesn't ask for a coffee break, and the repetition is entirely your problem to solve. This is how I solved it for my particular setup. Quick context on the setup. I run a self-hosted Kubernetes cluster at home, GitOps style, which means I describe what I want deployed in config files, push to Git, and the cluster reconciles reality to match the description automatically. Helm manages the packaging, Argo CD handles the sync. Terraform provisions cloud resources like DNS and firewall rules. Ansible handles the actual node setup. And there's a local web UI for day-to-day config management. If none of that means anything to you, the takeaway is, there are several layers, each with their own conventions, and keeping them straight in your head is a job unto itself. That's the environment I'm working in. And it's the environment I want the AI to understand without me re-explaining it every time. Here's the core problem. Infrastructure has a lot of implicit knowledge baked into it, not just the files themselves, but the conventions around them. Which field goes where? What names follow what pattern? Why certain things are configured the way they are? An AI can read your files, but it can't infer 6 months of accumulated decisions from the files alone. So you fill in the gaps every session by hand. The fix is something Claude Code calls skills. A skill is a bundle of context and instructions that gets loaded into the AI's session automatically. You define it once. After that, it just shows up. Skills are defined in a plain text file with some metadata, when to trigger, what to load, what behavior to enable. They can fire automatically based on which parts of the code base Claude is working in, or you can invoke them manually with a / command. There are 2 categories I find useful: context skills and task skills. Context skills fire automatically based on file paths. When Claude has to work with a Kubernetes manifest, a skill loads my cluster architecture, naming conventions, and chart structure. When Claude is working in the Terraform directory, a different skill loads how variables are sourced and what modules exist. When it touches Ansible, it knows the role layout and the inventory format. Each layer of the stack has its own context skill. The result is that Claude goes from "what's your setup?" to "I see you're adding a service. Here's how it should be structured given your chart layout," without me typing a single word of explanation. The AI hits the ground running every session on every file type automatically. That's context skills. Task skills are reusable workflows wrapped in a single command. Adding a new service to my cluster used to be a multi-step process. Write the Helm values, register it in the app list, validate the chart renders correctly, check for conflicts, run the template, then commit. Now it's one command. The skill knows the steps, knows the conventions, runs the validation, and flags anything off. Checking cluster status, git state, what's deployed, what recently changed, one command. Updating documentation after a code change, one command. The important thing, these aren't shell scripts. They're AI-driven workflows. So when I hit an edge case, Claude reasons through it instead of failing silently. If I wanted that same level of adaptive handling from an automation script, I'd be chained to the keyboard, tweaking every single line for every edge case. Let me show you what it looks like in practice. I'm going to validate a Helm chart after adding a new service. Here's everything in my current stack. Context skills for each infrastructure layer: Kubernetes, Terraform, Ansible, and my local Docker dev environment. These fire automatically and require no maintenance beyond keeping them current when the architecture changes, which Claude will do automatically, because we've configured it to do so. A deployment skill for adding or modifying services in the GitOps chart. This one does the heavy lifting. It knows the conventions, writes the values file, registers the service, and runs validation before committing. A validation skill that runs Helm template checks and YAML schema validation. I invoke this before any cluster-touching commit. A status skill for git state and deployment overview. Useful after a few days away from the cluster. And a docs skill that updates documentation when the code changes, because documentation that's always wrong is actively harmful. Total time to build all of this, a few hours across a couple of weekends. The return on that investment shows up every single session. Let me give you a concrete example of what this unlocks, one that would have taken me a full weekend manually. I wanted to do a security review of my cluster's network policies, so I asked Claude to scan the repo and figure out which apps were missing network policies. Because it already had full context of the codebase, it could map out app relationships, infer which services talk to which, and identify every application running without network isolation. Most of them, which is. Fine, it's a home lab, but still. I then asked it to propose network policies for each app based on the relationships it had already worked out and implement them. With minimal output, I didn't need a running commentary. Claude went through the repo, wrote the policies, and flagged a handful of apps it couldn't cover. The reason? Those apps were on deprecated Helm chart versions that didn't support network policies at all. And here's where having a well-contextualized AI pays off in a way that's hard to describe without sounding like a pitch. I said, "You already know the content of those deprecated charts. You already have skills that teach you how my infrastructure works. Why don't you migrate them?" And it did, all of them, on the first try. No manual intervention, no back-and-forth debugging, no half-finished migrations I'd need to clean up. Claude had everything it needed, the chart conventions, the value structure, the naming patterns, the app relationships, because we'd built that context in. The network policies were applied as part of the migration. What would have taken a weekend of careful manual work happened in about 20 minutes, including the time I spent typing the question. That's the compounding effect. Skills aren't just shortcuts, they're the foundation that makes complex work possible. If you're running a home lab and using any kind of AI assistant, skills are worth the setup time. Even a single context skill for your most complex layer saves you more time than it took to write, and the savings compound as you add more. Drop a comment with your setup. What stack you're running, whether you've tried anything like this, what's working and what isn't. I'm genuinely curious what other people are building. Next video, I'm going to build one of these skills from scratch, actual code, actual dead ends, actual debugging, so you can see exactly how it comes together. Subscribe so you don't miss it.